Greetings to all Chronojump users. I am Xavier Blas, main developer of Chronojump software and president of Chronojump Association. This video is addressed to Chronojump users on macOS. It's a technical video that explains why it has taken us so long to fix the problems that appeared after the release of macOS Sonoma, and with the arrival of Apple Silicon M1 and M2 chips. When Sonoma was released, we immediately began receiving reports that Chronojump crashed as soon as it's opened. For applications such as Chronojump, if a new version has a problem, you can revert to the previous version. But with operating systems, rolling back is rarely easy, and in macOS, there is no official rollback option. So, recommending users to return to a pre-Sonoma version was therefore not possible. The root cause of the bug was a change in the way Sonoma updates what is drawn on a screen. That change caused the graphs rendered by Chronojump to fail instantly, and the system shut the program down. Chronojump displays two kinds of graphs. Graphs that update constantly when the window is resized or when new data arrive, and graphs generated by R for specific calculations. The first type was the one that crashed. Once we had identified the problem, we published a version without the graphs, so that data could still be recorded, reviewed, and exported. We called this version Sonoma-No-Graphs, which at the time was the most practical solution. Nevertheless, we still had to solve the underlying issue because the number of Sonoma users kept growing. Every program relies on external libraries that provide many features. In our case, the conflict was in the Cairo graphics library. This library is packaged inside the JTK graphical toolkit. Cairo version was old, and updating it was far from easy. At that moment, Chronojump still used GTK 2, the Mono runtime, and the Cerbero build environment. We conclude that moving to GTK3.NET was the best path forward. Migration to this GTK version had already begun the previous year and was well advanced. But for the .NET part and for packaging, so the new build version will run on every operating system, we hired additional developers. Windows migration finished in about 6 weeks, although later bugs were fixed over time. Linux porting took about 3 weeks, but the interface is currently only in English and still needs translation. macOS migration took more than a year. During that year, we faced many issues, sometimes in parallel. Below are the most important. First one, Apple Developer Account Name. Our association legal name, Chronojump Association for Research and Dissemination of Technical Applied to Physical Activity, Technology Applied to Physical Activity and Sport, was too long for Apple. We proposed a shorter Chronojump Association. This process needed the review of the Apple legal department. The main problem was that although the legal name of our association is in Spanish, it's Asociación Chronojump para la Investigación y Difusión de la Tecnología Aplicada a la Actividad Física y el Deporte, and is registered under Spanish law, it was registered in Catalonia. And the legal documents are written in Catalan. Those documents contain very few words, and Catalan is co-official language in Spain. But Apple Spain does not accept documents in Catalan. Apple asked us to make an official translation into Spanish of the legal documents. Such a translation will have delayed the process even more. After a lot of emails, it was solved with phone calls to Ireland in English, And this approval process took around 2 months. The second reason that made all the process of migration too long, it was the Apple Store or App Store bureaucracy. Even for a free app like ours, you need to fulfill lots of financial paperwork. This paperwork is extensive. Third reason is the packaging limits in App Store. Submitting a GTK3 application that bundles Python and R is difficult. We considered migrating to GTK4, but finally we rejected because this will add months to the process. And in the end, we finally skip the App Store and distribute the app directly, but notarize it. The notarization of the certificates is a tedious problem, and it's error-prone. Not only it's complicated to have the certificates correctly installed in the different computers, also publishing can fail simply because Apple timestamping server is down. And this problem happens more often than you may think. The fifth problem is the requirements of hardware. We needed both an Intel and Apple Silicon Mac. As virtualization on Mac is no longer allowed, we had to purchase and manage 2 physical machines. This is a problem not only economical, but also logistically in entities like ours. With workers like myself, we alternate work in the office and work at home. And carrying 2 extra laptops continuously is not optimal. Sixth group of problems is related to the new version itself. First, we needed to address folder permissions errors when exporting. This was fixed under a month and fixed more or less easily because we found and fixed this problem previously in the Windows GTK3 version. Second is bundling an R and Python for both architectures, for Intel and for Silicon. This was difficult, and finally at this moment we are addressing the Silicon users to install these packages manually. Third and more important is the issues of SQLite databases in Silicon. This was the main problem, as we could not find a way to get SQLite to work in Silicon. SQLite is one of the most popular databases. It's widely used on both computers and phones, and we were surprised that we couldn't use it directly on Mac Silicon. When we managed to integrate it, the first problem we detected was that some databases tables were created with an incorrect order of the columns. This problem happened randomly in different tables on different computers. And this led us to modify the way that many of the tables were queried. We finally found a different implementation of SQLite that we use only for Silicon. Then we had problems also reading data from the serial port, the device access, in Silicon. For a couple of months, we thought that data captured with encoder was slow in Silicon because of the communication that Chronojump has with R during the capture and some kind of blocking process done by Silicon, forcing and analyzing the connections. This we thought that is the problem that makes everything slow. This led us to rewrite all the functions related to encoder capture that it was done in R, and we rewrite to another programming languages. Some of the calculations were very complex to perform without R, and therefore we need a different smoothing of the data. We needed to migrate to a different smoothing process of the data. Sorry. Many checks were made to try to make the data displayed in real time, similar to data displayed by error previously, and at the end of the capture. After having modified many files, we published a version without R and realized that it was still slow. So finally, we saw that the problem was not with the communication with R. So the problem was, in fact, reading the data coming through the serial port, the USB. The encoder is a Chronojump device that sends data continuously at a higher frequency of all the devices that we have in Chronojump. The way that Chronojump reads the data has worked without error on all the operating systems and all the computers we have used over the years. But for some reason, on Silicon, the reading was very slow, and some data is missed. We have modified the way data is read, and now it works perfectly. Unfortunately, all the functions and all the work that we have done to rewrite all the code to not use R have been worked in vain and took too long. Many of the problems stem from relying on dated libraries that were very costly to modernize. Long-lived projects like Chronojump, that as you know is 20 years old now, periodically face this kind of hurdles. Other problems came from Apple's distribution, certification, and notarization requirements. Thanks to Yang Desyu, thanks to Andoni Morales, to Nerea Casal, and to every user who helped identify the issues described in this video. Now we have a working version for Intel Mac and a working version for Sonoma Mac. And we are very proud of the process. It took too long, but the process, it ended correctly. Thank you for your time.